Hello everyone, myself Krishna Prasad is Assistant Professor, Department of Mechanical Engineering, MIT Mysore. Welcome you all for the lecture session 2 on the module 3 IC engine, refrigeration and air conditioning system. So in the previous class we have studied about what is meant by the heat engine, internal combustion engine, external combustion engine, classification of IC engine, parts of an IC engine as well as IC engine terminology. In today's class, we are discussing about the further part of the internal combustion engine chapter. It is called the working principle of 4-stroke petrol engine or a spark ignition engine and working principle of 4-stroke diesel engine or compression ignition engine and the difference between 4-stroke petrol and the diesel engine. Okay, so in the previous class, we studied about the details of the parts of an IC engine. The main parts of an IC engine, it is called as the cylinder, piston rings, connecting rod, crank, crankshaft, inlet valve, exhaust valve. So we already know what is meant by the cylinder. Cylinder is the heart of the engine in which the fuel is going to burn and power is going to develop, and the piston is nothing but is a cylindrical shaped component which perfectly fits inside the engine cylinder, in which it compresses the charge and power developed by the combustion of the fuel is transmitted from the piston to the crankshaft through the intermediate mechanisms like crank and the connecting rod. And the piston rings are the metallic rings. It is inserted into the circumferential grooves provided at the top end of the piston, and there are two types of ring. The one is called compression ring, other one is called oil ring. Then the next one, it is called what is meant by the connecting rod. So connecting rod forms a link between the piston and the crankshaft. That means here the main function of the connecting rod is to convert reciprocating motion of the piston into the rotary motion of the crankshaft. And it is very important one, it's called crank. So crank forms the link between the connecting rod and the crankshaft. And the two valves what we are used, it is called as the inlet valve and the exhaust valve. So inlet valve allow the fresh charge of air petrol mixture enters into the engine cylinder, and exhaust valve allows the expel out of burnt gases from the engine cylinder into the atmosphere. And very important one, it is called as the igniter. So igniter in case of the petrol engine, it is called as the spark plug, and igniter in case of the diesel engine, it is called as the fuel injector. So your spark plug is used to ignite the air fuel mixture present inside the engine cylinder. And the flywheel, it is a heavy wheel mounted on the crankshaft of the engine. It stores the energy during the power stroke and supply the same energy during the other 3 strokes, that is called as the flywheel. Then crankshaft, it is drive the various other parts of the vehicle, and the crankcase acts as a lower part of the engine and it serves as a sump for the lubricating oil. So next very important one, it is called as the 4-stroke petrol engine. That means working of the 4-stroke petrol engine or spark ignition engine. So in case of the petrol engine, very important one, it is called spark plug. It is used as a injector. So that means it will going to burn the air fuel mixture present inside the engine cylinder and power is going to develop. So what is meant by the 4-stroke petrol engine? Why it is called 4-stroke petrol engine? In case of the 4-stroke petrol engine, your working cycle completed in 4 different strokes and 2 revolutions of the crankshaft. That is very important. I repeat, so what is meant by the 4-stroke petrol engine? In case of the 4-stroke petrol engine, your working cycle completed in 4 different strokes and 2 revolutions of the crankshaft. As well as 4-stroke petrol engine, it is works on theoretical Otto cycle, and it is also known as constant volume heat addition cycle. And what are the 4 different strokes of the 4-stroke petrol engine? So first one, it is called suction stroke, and second one, it is called compression stroke, third one, it is called power stroke, and fourth one, it is called exhaust stroke. So, and I already told your working cycle completed in 4 different strokes and 2 revolutions of the crankshaft. So 2 revolutions of the crankshaft means here 0 to 720 degree. Okay, so how the working is going to happen in case of the suction stroke, later compression stroke, then power stroke, and last exhaust stroke we are going to see. And what will be the variation of pressure and volume with respect to the 4-stroke petrol engine, we need to see in the pressure and the volume diagram. So in case of the examination, generally we are going to ask how the working of 4-stroke petrol engine or spark ignition engine explained with the help of the PV diagram. So that's why, so working of the PV diagram, it is also very much important. So first stroke, it is called as the suction stroke. What is mean by the suction stroke? So what are the conditions of the suction stroke? That is very much important. In the suction stroke, inlet valve is open and exhaust valve is closed. Okay, and here piston moves from top dead center to the bottom dead center. Here we are abbreviated as top dead center as TDC and the bottom dead center as BDC. Okay, so in the suction stroke, inlet valve is open and exhaust valve is closed, and the piston moves from top dead center to the bottom dead center. And here, due to the downward moment of the piston, a suction is going to created inside the engine cylinder. Okay, due to the downward moment of the piston, a suction is going to created inside the engine cylinder. Then discharge of air petrol mixture is enters into the engine cylinder through the inlet valve. When the piston is reaches the BDC position, observe here, this is the starting point of the suction stroke and this is the ending point of the suction stroke. So when the piston reaches the BDC position, then inlet valve is closed and the suction stroke is going to end. Okay, and here suction stroke, it is represented by line AB on the PV diagram. Okay, so suction stroke, it is represented by line AB on the PV diagram, and during the suction stroke crankshaft rotates 0 to 180 degree, that means 1/2 of the revolution. Okay, so in the PV diagram here pressure is kept constant and volume is increases. So why volume is increased? Observe here, during the suction stroke piston moves from top dead center to the bottom dead center, hence the volume is going to increases. So increase in volume, it is represented by line AB. But here inlet valve is open to the atmosphere, hence the complete engine cylinder, it is acts with the atmospheric pressure, therefore pressure is constant during the suction stroke. Okay, so this is regarding to the suction stroke. Then what happens in case of the compression stroke? So in case of the compression stroke, again observe the inlet valve and the exhaust valve. In the compression stroke, inlet valve and exhaust valves are completely closed, and here piston moves from bottom dead center to the top dead center. So when the piston moves from bottom dead center to the top dead center, crankshaft rotates another half of the revolution, therefore the rotation of the crankshaft, it is given in terms of 180 to 360 degree. Okay, due to the upward movement of the piston, the pressure and temperature of the air fuel mixture, the pressure and temperature of the air petrol mixture is going to increases. Okay, so due to the upward movement of the piston, pressure and temperature of the air fuel mixture is going to increases, and at the end of the compression stroke, okay, at the end of the compression stroke, so the figure 2, it is called as the starting of the compression stroke, and figure 3, it is called as the ending of the compression stroke. Here at the end of the compression stroke, the volume is remains constant for the small displacement. So that is called VC. So VC, it is called nothing but clearance volume. So in the previous session I told what is meant by the clearance volume. So clearance volume, it is nothing but it is the volume of the cylinder above the piston when the piston it is at TDC position. Okay, so at the end of the compression stroke, the volume is remains constant for the small displacement. So this is regarding to the compression stroke. Here compression stroke, it is represented by line BC, and here the combustion at a constant volume, it is represented by line CD on the PV diagram. Okay, observe here, during the upward movement of the piston, the pressure and temperature of the air fuel mixture is going to increases, and at the end of the compression stroke, the volume is remains constant for the small displacement, and the combustion of the fuel is going to take place at a constant volume. So that's why it is called as the theoretical Otto cycle. So here compression stroke, it is represented by line BC on the PV diagram, and combustion at a constant volume, it is represented by line CD on the PV diagram. So this is regarding to the compression stroke. Then we are moving on to the power stroke. Okay, so what is mean by the power stroke? So in the power stroke, both inlet and exhaust valves are closed, and very important one here, the high pressure and high temperature of air fuel mixture catches the fire from the spark plug, hence high amount of energy is liberated, and this pushes the piston from top dead center to the bottom dead center. I repeat, here both inlet and exhaust valves are closed, and high pressure and high temperature of air fuel mixture catches the fire from the spark plug, hence high amount of energy is liberated and this pushes the piston from top dead center to the bottom dead center, and during the stroke the crankshaft rotates further half of the rotation, that is 360 to 540 degree. When the piston reaches from top dead center to the bottom dead center, so flywheel stores the energy during the power stroke. Okay, so flywheel stores the energy during the power stroke and at the end of the power stroke, I repeat, here the power stroke, it is the beginning of the power stroke and it is the end of the power stroke. That is, at the end of the power stroke, the exhaust valve is open. Okay, so at the end of the power stroke, exhaust valve is open, hence sudden drop in pressure is going to take place. Okay, so sudden drop in pressure, how to represent? Here power stroke, it is represented by line DE, and sudden drop in pressure, it is represented by line EB. Okay, so again observe here the sudden drop in pressure, here pressure is going to decreases, here volume is constant, here only exhaust valve is open but the volume is does not going to change, that's why it is represented by line EB. Then the last one, it is called as the exhaust stroke. So what is meant by the exhaust stroke? In the exhaust stroke, inlet valve is closed but exhaust valve is open, and here piston moves from bottom dead center to the top dead center. Due to the upward movement of the piston, whatever the burnt gases present inside the engine cylinder like carbon monoxide, carbon dioxide, nitrogen dioxide, sulfur dioxide, these gases must be expelled out from the engine cylinder into the atmosphere through the exhaust valve. So this is called as the exhaust stroke. During the exhaust stroke, crankshaft rotates further half of the rotation, that is 540 to 720 degree. So therefore the working cycle completed in 2 revolutions of the crankshaft and the 4 different stroke. And here the exhaust stroke, it is represented by line BA on the PV diagram. Okay, this is regarding to the working of 4-stroke petrol engine or spark ignition engine. Okay, I repeat once again. So what is the working of the 4-stroke petrol engine or spark ignition engine? So very simple. Here working cycle completed in 4 different strokes and 2 revolutions of the crankshaft. And here 4-stroke petrol engine, it operates on theoretical Otto cycle and it is also known as constant volume heat addition cycle. So in the suction stroke, inlet valve is open and exhaust valve is closed. Okay, so and the piston moves from top dead center to the bottom dead center. Due to the downward movement of the piston, suction is going to create inside the engine cylinder. Hence, fresh charge of air petrol mixture is enters into the engine cylinder. And during the suction stroke, crankshaft rotates 0 to 180 degree. And at the end of the suction stroke, inlet valve is closed. Here suction stroke, it is represented by line AB on the PV diagram. Next, compression stroke. During the compression stroke, both inlet and exhaust valves are closed and piston moves from bottom dead center to the top dead center and crankshaft rotates 180 to 360 degree. Due to the upward movement of the piston, the pressure and temperature of the air fuel mixture is going to increases. Okay, then at the end of the compression stroke, the volume remains constant for the small displacement, hence it is called as the constant volume heat addition cycle. And here compression stroke, it is represented by line BC, and combustion at a constant volume, it is represented by line CD. Then power stroke. So in the power stroke, both inlet and exhaust valves are closed and here piston moves from top dead center to the bottom dead center. How the piston moves from top dead center to bottom dead center? Because whenever high pressure and high temperature of air fuel mixture catches the fire from the spark plug, then high amount of energy is liberated, that pushes the piston from TDC to BDC position. Okay, and at the end of the power stroke, exhaust valve is open, hence sudden drop in pressure is going to takes place. Okay, so here power stroke, it is represented by line DE and sudden drop in pressure is represented by line EB, and at the end it is called exhaust stroke. So exhaust stroke, here inlet valve is closed and exhaust valve is open, and here piston moves from bottom dead center to the top dead center and crankshaft rotates 540 to 720 degree. So due to the upward movement of the piston, whatever the burnt gases present inside the engine cylinder like carbon dioxide, carbon monoxide, nitrogen dioxide, sulfur dioxide are expelled out through the exhaust valve into the atmosphere. So this is regarding to the working of the 4-stroke petrol engine. Here AB represents the suction stroke, BC represents the compression stroke, CD represents the combustion at a constant volume, and DE represents the power stroke, EB represents the sudden drop in pressure, and BA represents the exhaust stroke. The next topic, it is called 4-stroke diesel engine. So the working of the 4-stroke diesel engine is almost similar to the 4-stroke petrol engine. Okay, so here in case of the 4-stroke diesel engine, here working cycle completed in 4 different strokes like suction stroke, compression stroke, power stroke, and exhaust stroke, and working cycle is also completed in 2 revolutions of the crankshaft. So 2 revolutions of the crankshaft means, so in order to perform the suction stroke to the exhaust stroke, crankshaft has to revolve 2 times. That means 0 to 720 degrees. That is very much important. Then in case of the 4-stroke diesel engine, instead of the spark plug, it is replaced with the fuel injector, and the fuel injector, it is connected to the fuel pump in order to supply the diesel oil during the power stroke. So that is very much important in case of the 4-stroke diesel engine. So the working of the 4-stroke diesel engine, it is mainly depends upon the diesel cycle. So diesel cycle, it is nothing but here combustion of the fuel takes place at a constant pressure, and it is works on the theoretical diesel cycle. Then main parts of the 4-stroke diesel engine, it remains the same. That is called cylinder is the heart of the engine. Then piston is perfectly fits inside the cylinder, and it is reciprocates inside the engine cylinder, and whatever the power developed due to the combustion of the fuel from the piston is transferred to the crankshaft through the intermediate mechanisms like crank and the connecting rod. Then here connecting rod, it forms the link between the piston and the crankshaft. It converts reciprocating motion of the piston into rotary motion of the crankshaft. Then crank acts as a lever. It is connected to the connecting rod at the one end and crankshaft at the other end. Then crankcase, it acts as a lower part of the engine. It serves as a sump for the lubricating oil. So this is regarding to the main parts of the 4-stroke diesel engine. Then very first stroke in case of the 4-stroke diesel engine, it is called as the suction stroke. So what happens in case of the suction stroke, that is very much important, and what are the conditions we need to take during the suction stroke of the 4-stroke diesel engine, it is also very much important. So observe here, during the suction stroke, inlet valve is open and exhaust valve is closed, and here piston moves from top dead center to the bottom dead center, and due to the downward moment of the piston, here crankshaft rotates 0 to 180 degree, and also due to the downward moment of the piston, a small suction is going to created inside the engine cylinder. Hence only fresh air is enters into the engine cylinder through the inlet valve. Okay, and at the end of the suction stroke, observe here, so this is the starting point of the suction stroke and it is the ending point of the suction stroke. At the end of the suction stroke, here inlet valve is going to closed. Okay, at the end of the suction stroke, inlet valve is going to closed and crankshaft rotates 0 to 180 degree, and here the suction stroke, it is represented by line AB on the PV diagram. Here the suction stroke in case of the both petrol engine and diesel engine is almost the same. The only difference, it is called here only fresh air is enters into the engine cylinder through the inlet valve. So that is very much important. So next one, it is called what is meant by the compression stroke. Observe here, what happens in case of the compression stroke. In case of the compression stroke, both the inlet and exhaust valves are closed, and here piston moves from bottom dead center to the top dead center, and due to the upward movement of the piston, here crankshaft rotates another half of the rotation. It is called 180 to 360 degree. Okay, next, due to the upward movement of the piston, the pressure and temperature of the air is going to increases. Okay, due to the upward movement of the piston, the pressure and temperature of the air is going to increases, and at the end of the compression stroke, so this is the beginning of the compression stroke and this is the end of the compression stroke. At the end of the compression stroke, here pressure remains constant for the small displacement. That means here combustion of the fuel takes place at a constant pressure. So this is called it as the regarding to the compression stroke. Then here compression stroke, it is represented by line BC, and combustion at a constant pressure, it is represented by line CD. Okay, understand? So I repeat, so in case of the compression stroke, both the inlet and exhaust valves are closed and the piston moves from BDC to TDC, hence crankshaft rotate 180 to 360 degree. Okay, so due to the upward movement of the piston, pressure and temperature of the air is going to increases, and at the end of the compression stroke, here the pressure remains constant for the small displacement. That means here combustion of the fuel is going to take place at a constant pressure. So that means here compression stroke it is represented by line BC, and combustion at a constant pressure it is represented by line CD. Then third one, it is called as the power stroke. So what happens in case of the power stroke? So in case of the power stroke also, both the inlet and exhaust valves are closed. Okay. So then high pressure and high temperature of air is going to burn when diesel oil is sprayed from the fuel injector. I repeat, the high pressure and high temperature of air is ignited when diesel is sprayed from the fuel injector. So this produces the high amount of energy, and this pushes the piston from TDC to BDC. So when the piston moves from TDC to BDC, crankshaft rotates 360 to 540 degree, and here the flywheel is going to store the energy during the power stroke and as well as at the end of the power stroke. So this is the beginning of the power stroke and this is the ending of the power stroke. At the end of the power stroke, an exhaust valve is open and sudden drop in pressure is going to take place. Okay. So power stroke, it is represented by line DE, and sudden drop in pressure it is represented by line EB. So this is regarding to the power stroke. Then last one, what happens in case of the exhaust stroke? So in the exhaust stroke, inlet valve is closed and the exhaust valve is open. So and the piston moves from bottom dead center to the top dead center, and due to the upward movement of the piston, whatever the burnt gases present inside the engine cylinders like carbon monoxide, carbon dioxide, nitrogen dioxide, sulfur dioxide should be expelled out into the atmosphere through the exhaust valve. That's why exhaust valve is open. Okay. So during this, exhaust valve is entered to the atmosphere. Therefore, here pressure remains constant, but the volume is going to decreases. So decrease in volume is represented by line BA, and pressure is constantly represented by line AB. So this is regarding to the exhaust stroke. Okay. So that means now your working cycle is completed in 4 different strokes like suction stroke, compression stroke, power stroke and exhaust stroke, and the 2 revolutions of the crankshaft from 0 to 720 degree. Okay. So I repeat, so what is the working of the 4-stroke diesel engine? Here instead of the spark plug we have to replace with the fuel injector. So first one it called suction stroke. In the suction stroke, inlet valve is open and exhaust valve is closed. Okay. So and the piston moves from TDC to BDC. Due to the downward movement of the piston, a small suction is going to created inside the engine cylinder. Hence only a fresh air is enters into the engine cylinder through the inlet valve, and at the end of the suction stroke, here inlet valve is closed and suction stroke it is represented by line AB. Then compression stroke. So in the compression stroke, both the inlet and exhaust valves are closed, and your piston moves from TDC to BDC, hence crankshaft rotates 180 to 360 degree. Okay. So here due to the upward movement of the piston, pressure and temperature of the air is going to increases, and at the end of the compression stroke, here pressure remains constant for the small displacement. Here compression stroke it is represented by line BC, and combustion at a constant pressure is represented by line CD. Then power stroke. So during the power stroke, both inlet and exhaust valves are closed, and at the beginning of the power stroke, here high pressure and high temperature of air is ignited when diesel is sprayed from the fuel injector. Hence high amount of energy is liberated, and this pushes the piston from TDC to BDC, and flywheel is going to store the energy during the power stroke. Then at the end of the power stroke, your exhaust valve is open, hence sudden drop in pressure is going to take place. Here power stroke it is represented by line DE, and sudden drop in pressure is represented by line EB. Then last one, exhaust stroke. So in the exhaust stroke, inlet valve is closed and exhaust valve is open, and piston is moves from BDC to TDC position. So due to the upward movement of the piston, whatever burnt gases present inside the engine cylinder is expelled out through the exhaust. So this is regarding to the working of the 4-stroke petrol engine as well as the 4-stroke diesel engine. So next we are discussing about the difference between the 4-stroke petrol engine as well as the 4-stroke diesel engine. The last topic, the today's session, it is called the difference between the 4-stroke petrol engine as well as the 4-stroke diesel engine. So we already studied what is the working of the 4-stroke petrol engine as well as the diesel engine. Based on the description, we are categorized some of the differences between the 4-stroke petrol engine and the diesel engine. Okay. So some of the differences like, So theoretical cycle. So the theoretical cycle of the 4-stroke petrol engine, it is also called as the Otto cycle. So what is mean by the Otto cycle? Here combustion of the fuel takes place at a constant volume, then it is called as the Otto cycle. Similarly, in case of the 4-stroke diesel engine, here combustion of the fuel takes place at a constant pressure, then it is called it as the diesel cycle. So this is the first difference, that is called based on the thermodynamic cycle or theoretical cycle. Then second one, it is called type of fuel used. So in case of the petrol engine, the fuel used, it is called it as the petrol, then that's why it is called it as the petrol engine. So but in case of the diesel engine, the fuel used, it is called it as the diesel, then it is called it as the diesel 4-stroke diesel engine. So in the classification itself we told, so based on the type of fuel used, it is categorized into 4 types. It's called petrol engine, diesel engine, gasoline engine and bi-fuel engine. Then third one, admission of the fuel. So when the fuel is going to admitted into the engine cylinder, that is also very much important. In case of the 4-stroke petrol engine, during the suction stroke itself, the fresh charge of air petrol mixture is enters into the engine cylinder through the inlet valve. Okay, but what happens in case of the 4-stroke diesel engine? So in case of the 4-stroke diesel engine, only fresh air is enters into the engine cylinder during the suction stroke through the inlet valve, but diesel oil is sprayed from the fuel injector with the help of the fuel pump during the power stroke. That is very much important in case of the 4-stroke diesel engine. Next, fourth one, the charge drawn during the suction stroke. So during the suction stroke, in case of the 4-stroke petrol engine, both air and the petrol mixtures are drawn in the cylinder through the inlet valve in the suction stroke. But in case of the 4-stroke diesel engine, only fresh air is drawn into the engine cylinder through the inlet valve during the suction stroke. That is very much important. Then what is mean by the compression ratio? So compression ratio we are already studied, it is nothing but it is the total volume to the clearance volume. So in case of the 4-stroke petrol engine, the maximum compression ratio we can achieve in the clearance volume, it is only 7:1 to the 12:1. Okay, that means here 7 it indicates the percentage of air and 1 it is indicates the percentage of fuel. But in case of the diesel engine, here combustion of the fuel takes place at a constant pressure, hence the compression ratio is going to increases, that is from 16:1 to the 20:1. That is very much important during the 4-stroke diesel engine. Next one, it is called ignition of the fuel. So in case of the 4-stroke petrol engine, here ignition of the fuel takes place with the help of the spark plug. That means here spark plug ignites the fresh air fuel mixture during the power stroke. That's why 4-stroke petrol engine, it is also called as the spark ignition engine or SI engine. So next one, in case of the 4-stroke diesel engine, here very simple, when hot compressed air is contact with the diesel oil sprayed from the fuel injector, then combustion of the fuel is going to take place. That's why here compressed air is very much important. That's why 4-stroke diesel engine, it's also called as the compression ignition engine. Next, noise and vibration in case of the 4-stroke petrol engine. So noise and vibration is very much less in case of the 4-stroke petrol engine because of the lower operating pressure, because here compression ratio we can achieve only from 7:1 to the 12:1. But what about in case of the diesel engine? Here higher operating pressure is obtained, therefore here the noise and vibration in case of the diesel engine vehicles are very much high compared to the 4-stroke petrol engine. Next one, thermal efficiency. So thermal efficiency of the 4-stroke petrol engine is less compared to the 4-stroke diesel engine because of the lower operating pressure, and in case of the diesel engine, it is comparatively high compared to the petrol engine because of higher operating pressure. Then power developed. So power developed in case of the 4-stroke petrol engine, it is very less compared to the 4-stroke diesel engine because of the lower operating pressure, but in case of the 4-stroke diesel engine, it is very high compared to the 4-stroke petrol engine because of higher operating pressure. Then the uses of the petrol engine in the vehicles like scooter and the motorcycle, mopeds, even in the car. But the 4-stroke diesel engine, it's normally uses in the bus, truck, tipper and even the car can be obtained with the 4-stroke diesel engine. And last one, initial and maintenance cost. The initial and maintenance cost of the 4-stroke diesel petrol engine vehicles are very much less compared to the 4-stroke diesel engine vehicle, because in case of the 4-stroke diesel engine vehicles, operating pressure is very high and the lubrication is also very much important. So because of that, here the initial cost as well as the maintenance cost is very much higher in case of the 4-stroke diesel engine. Okay, so some of the important points in case of the differences we need to observe. First one, it's called theoretical cycle, that is called Otto cycle and diesel cycle. Then fuel used, it is very simple. If it is petrol, then it's called petrol engine. If it is diesel, then it is called diesel engine. Then admission of the fuel here during the suction stroke itself, but here during the power stroke. So then charge drawn during the suction stroke, both air and a petrol, but here only air. Then compression ratio is very much important. It is very less, that is 7:1 to 12:1, but here 16:1 to 20:1. Then based on the ignition of the fuel, so here petrol engines are called as the spark ignition engine, compression ignition engine is called 4-stroke diesel engine. Then here, so what are the uses? The uses of the 4-stroke diesel engine vehicles like scooter and a motorcycle, but 4-stroke diesel engine vehicles are truck and a bus. Then initial and maintenance cost less in the petrol engine and more in the diesel engine. So these are the some of the major differences we can see in case of the 4-stroke petrol engine as well as in the diesel engine. Thank you.